everybody. Today we're going to do some notes. A lot of it's going to be review, some of it new. You're going to see some new terminology coming in here. So we're just going to kind of go through this notes sheet and grab some new terminology along the way. So let's just start with number 1. We're still studying Riemann sums. This kind of still lumps under that title. So number 1 says, sketch the graph of f of x equals negative 2x plus 10 on the interval from 1 to 4. Okay, so that's exactly what I'm going to do. So, take my pen here. So if I section off from 1 to 4, I'm going to plug these values of x into my function. So f of 1 will be negative 2 times 1 plus 10, which is 8. So 1, 2, 3, 4, 5, 6, 7, 8. F of 2, negative 2 times 2 plus 10 will be 6. You can see I'm coming down to right 1, which is what my slope says. F of 3 will be 4. And f of 4 will be 2. So this is my graph from 1 to 4. And I'm just going to kind of drop these sidebars down here to section off the area trapped between the function and the x-axis. Okay, let's go to number 2. So number 1 we accomplished. Let's go to number 2. It says, using your sketch from number 1, underestimate the area trapped between f of x and the x-axis on the interval from 1 to 4 by drawing, here's our terminology, 3 right-hand rectangles. Finding the area of each of the 3 rectangles and adding the areas together. Now when we developed the formula for Riemann sums, we did right-hand rectangles, so these should be familiar to you. So let's take a look. So let's find our delta x, which is going to give us the width of each of our rectangles. We know delta x to be the formula b minus a divided by n. So for us in this particular example, our b is 4, our a is 1, and our n is right here, 3. We're not going to let n approach infinity on this one since they're giving us a finite number of rectangles to make. So 4 minus 1 divided by 3 gives us a delta x of 1 unit. So if I kind of section that off in my graph above, you can see I'm going to have 1 rectangle, 1 unit wide, a second rectangle, 1 unit wide, and a third rectangle that's 1 unit wide. Now, I need to find the heights. So since I'm finding right-hand rectangles, what I'm going to do is, between 1 and 2, I'm going to choose the right side of the subinterval, which is 2. I'm going to evaluate the function's height at 2, in other words, find f of 2, come across here horizontally, and drop down. So there's my first right-hand rectangle. Notice it's the upper right-hand corner of the function that is touching my graph. Okay. My next rectangle will run from 2 to 3. 2 to 3, I'm going to go to the right side, which is 3, come up, f of 3, touch on the right upper corner, come across and down, there's rectangle number 2. And finally, from 3 to 4, pull up on the 4, f of 4, across and down. So there are my 3 rectangles. So I have to find the area of each one separately, so I'm going to call that area 1, area 2, and area 3. Because the area of a rectangle is length times width, I'm going to put that in there just so we're clear. And then, of course, my length for each rectangle is 1 unit. That's consistent. So 1, 1, 1. It's the heights that vary, or my widths that vary. So let's grab these. So f of 2 was 6. So I'm doing f of 2 here. So 1 times 6 is 6. Next, we have to find f of 3 for my next height. So 1 times f of 3 is 1 times 4, which is 4. And finally, my f of 4, my final height, f of 4, is 1 times 2, which is 2. Add those all together. 12 units squared is my underestimate. Let's talk about why that's an underestimate. Well, if you look, we have this area right here that was untouched, this area right here and this area right here. So now, since my function is decreasing, it seems that these right-hand rectangles are underestimating the true area because we're missing out on these pink sections. So the true area is going to be more than 12 units squared. Okay, let's go to number 3. Number 3 says, using your sketch from number 1, overestimate the area trapped between f of x and the x-axis on the interval 1 to 4 by drawing 3 left-hand rectangles, finding the area of each of the 3 rectangles, and then adding those areas together. Tell you what I'm going to do. Even though I said you could use your sketch from number 1, because this is the first example, I think it might be smarter to just make a new sketch so that we don't confuse the two. So if I just draw a new sketch, and that is just what it's going to be, a sketch. Here's my x-axis, here's my y-axis. I'm going from 1 to 4, 1, 2, 3, 4, and I know that my function just decreases here, and that should suffice. Okay, so my delta x again is just going to be 4 minus 1 divided by 3. So I'm still working with 3 left-hand rectangles, so each rectangle will have that length of 1 unit. Here's the difference. I'm doing left-hand rectangles this time. So that means between 1 and 2, I don't want to pull up on the 2. That's the right side of the interval. I want left-hand rectangles, so I'm going to pull up at the 1. So I'm going to do f of 1, come across, and down. Notice the upper left corner is touching the function. From 2 to 3, I'm going to pull up on the 2, the left side, touch, across, and down. And from 3 to 4, I'm going to pull up on the 3, f of 3, across, and down. It's the upper left-hand corner that's touching. So here are my 3 rectangles that I have to find the area of. So coming over here, I have area 1, area 2, area 3. Okay, length times width for each one. And my lengths are consistent, 1 unit, 1 unit, 1 unit, 1, 1, 1. But now, when I find my heights, my first height here is going to be f of 1, then f of 2, then f of 3. So f of 1, f of 2, f of 3. So, if I plug f of 1, if I plug 1 back into my original function, I get 8. If I plug 2 back in, I get 6. And if I do f of 3, I get 4. And when I add these together, I get 8 plus 6 plus 4, which is 18 units squared. This is going to be an overestimate, and you can see it. If I highlight in pink where our error lies, it's right here. We have too much of our rectangle hanging out over top of the function. So now I know that my true area lies somewhere between 12 and 18 units squared. Okay, last question on the front. It says, using your sketch from number 1, estimate the area trapped between f of x and the x-axis on the interval 1 to 4 by drawing 3 midpoint rectangles, finding the area and adding them together. So this is new terminology, midpoint rectangles, but you can probably guess what these are. 3 midpoint rectangles. So again, I'm not going to use my drawing. It'll get too messy. So I'm just going to re-sketch this here. Here's my f of x and my x. And I know I'm going from 1 to 4. And my function starts at 1,8 and decreases here to 4,2. Drop my sides down. Okay, so now we've got a new drawing to work with. Okay, so here's what a midpoint rectangle will do. What it'll do is, again, they want 3 of them, so delta x does not change. 4 minus 1 over 3 still gives me 1 unit for my length of each rectangle. So we're going 1 to 2, 2 to 3, and 3 to 4. That creates my 3 rectangles. But here's what a midpoint rectangle will do. It will not evaluate f of 1. It will not evaluate f of 2. What it will do is it will go to the midpoint of the subinterval. In this case, it will go to 1.5. you will find f of 1.5, which will give you the function's value when x is 1.5, the midpoint. And you will mimic the base length here, coming across horizontally, and you will drop your sides of your rectangle. Now, what's interesting in the midpoint rectangle, especially you can see it so clearly on a linear function, you've got a little bit over and a little bit under. But what ends up happening when you're linear is what is over mimics what is under, and they kind of cancel each other out, which is kind of nice. Okay, so there's my first area. Okay, so then between 2 and 3, I'm going to not go to 2, not go to 3, I'm going to go to 2.5. Midpoint, come up, evaluate the function's height, get it right there. So it's the middle of the top side of your rectangle that's touching the actual function. Not the upper right corner, not the upper left corner, but the upper middle. Again, you can see how, sorry, this is really small, but you can see how the over and the under mimic each other. There's my second rectangle. And finally, 3 to 4, go to 3.5, come on up, come across, drop down, and there is that final area. And again, that pink over and under match up. So here's my final area, though. Here's how you work it out. You have your area 1, your area 2, your area 3. They're still 1 unit each in length, 1, 1, 1, but now you're grabbing your heights, f of 1.5, f of 2.5, and f of 3.5. So, if you plug 1.5 into your function, you get 7. If you plug 2.5 into your function, you get 5. And if you plug 3.5 in, you get 3. So we're talking 7 plus 5 plus 3, which makes a final area of 15 units squared, which is nice because that does lie between 12 and 18. So we seem to be honing in on the true area as we go along here. And tune into the next video for the back side of this example.